This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video, I'm going to be talking about how we find the equation of a tangent to a circle at a given point. So the way we find the equation of a tangent to a circle at a given point is by the following steps. Step 1 is to find the slope of the radius to the point of contact. So in the diagram that we have down here on the bottom right, we want to find the slope of this line here from the center of our circle to our point of contact here labeled P. Then we turn this slope upside down and change the sign. This gives us the slope of our tangent line. Because if we turn the slope upside down and change the sign, then the two lines will be perpendicular, because if the slope of the first line is A over B, for example, if we flip this and change the sign, we get minus B over A. And if we multiply those two values, A over B multiplied by minus B over A, we get an answer of minus 1, which, as you might remember, is the answer that we need to get to show the two lines are perpendicular. So now we have the slope of our tangent line here in green, and we know that the point of contact P is on that line, so then we can use the coordinates of the point of contact P in this case, and the slope of the tangent, this green line labeled T. We use those two values in the formula y minus y1, so y1 is the y coordinate of P here, m is the slope of your line, the green slope here, and x1 is the x value of your point of contact. Then you can find the equation of the tangent. So now I'm just going to go through an example of how we go about finding the equation of a tangent. So we've been asked to find the equation of the tangent to the circle x squared plus y squared equals 10 at the point minus 3, minus 1. So first, if we just draw ourselves a little picture to get an idea of what we need to do, we'll have our circle, and our point, say, is here at minus 3, minus 1. We will of course have a line which goes from the center of our circle to this point, and then we will have our tangent line which is perpendicular to that. So our tangent line here so we need to find the equation of this tangent line. And of course, we know, given the form of the circle that we're given here, that the center of this circle is at the point 0, 0. So our first step was to find the slope of the radius to the point of contact, this point down here. So to do that, we need to find the slope between the 2 points 0, 0 and minus 3, minus 1. So to do that, to get our slope between 0, 0 and minus 3, minus 1, we're going to use our formula y2 minus y1 over x2 minus x1, or r rise over r run, which is equal to 0 minus our minus 1, our y2, over 0 minus our minus 3, our x1. And that gives us a slope of 1 over 3, 1/3. Our next step was to get the slope of our tangent line, so our blue line over here, And we do that by flipping this value here and changing the sign. So slope of our tangent will be, in this case, minus 3, or minus 3 over 1 if you prefer. So now we have our slope is minus 3, we have our point on the line, minus 3 minus 1. So now we fill these values into our equation. Y minus y1 equals m, our slope, times x minus x1. So filling our values in, we have y minus, our y1 is minus 1 from here, equals m is minus 3, our slope, times x minus minus 3, our x coordinate of the point of contact here. Simplifying this a little bit, on the left we have y plus 1, and on the right we have minus 3 times x plus 3. So we have y plus 1, multiplying out the bracket over here, we have minus 3x minus 9. And then bringing everything to one side of the equals by adding 3x and 9 to both sides. We get our equation of our line to be y plus 3x plus 10, because we have 9 plus 1, is equal to, and on the right hand side here we just cancel and cancel to get 0. So the equation of our line and our final answer is y plus 3x plus 10 equals 0.